This is a flip video about other types of decomposition reactions. So we've already learned the basics of decomposition, and that is when a compound breaks into its two simple elements. So when AB breaks into A plus B. We're now going to look at two other types, and they involve chlorates and carbonates. So they involve compounds that have chlorates and carbonates. So let's first look at chlorates. So if you remember, chlorate is ClO3, okay? So here is a generic chlorate reaction. And what we have here is, in this reaction, we have M stands for metal, ClO3 is the chlorate, and it breaks down into the metal plus the chlorine, so we got the metal and the chlorine breaking down, and oxygen as the other product. So you always have whatever the metal is connecting with the chlorine and oxygen being released. Remember, oxygen when it's by itself is diatomic. And if you notice, I balanced this in order to balance the oxygen from the chlorate. Okay, remember, chlorate is a polyatomic ion. All right, and let's look at the other type before we practice, and that is carbonates. Remember, carbonate is another polyatomic ion, CO3. Okay, let's bring this up a little bit. And so in this generic example as well, I have a metal bonding with a carbonate, and it decomposes into a metal with oxygen plus CO2. So you always get carbon dioxide and the metal bonding up with just the oxygen. It is good to memorize these basic breakdowns. These are kind of two unique decomposition reactions. Okay, let's take a look at some examples now and try to see if we can figure them out. So we have KClO3, right? Looks like it's a basic decomposition when in fact I recognize that there's a chlorate in it. ClO3 is chlorate. Okay, so you have to be able to recognize chlorate, which is right here. I look back at the notes I've written down and realize that if I have a metal with ClO3, here's my metal, potassium with ClO3, this is the basic format. So let's go ahead and predict the products. I notice that on this side, my metal teams up with chlorine. So here's my metal, K, and it has a charge of +1. Anytime things come together, you have to balance their charges, and chlorine has a charge of -1, so KCl. And generally speaking, this KCl is going to be a solid. So this metal that pairs up with my nonmetal is going to be a solid. And what gets knocked off? Just oxygen gas. So O2 with a gas. All you have to do now is to balance it. There we go. 2 Ks, 2 Ks, 2 Cls, 2 Cls, 6, 3 times 2 is 6 oxygens, 6 oxygens. So here's the decomposition of potassium chlorate into potassium chloride and oxygen. All right, good. Now let's take a look at another example. How about this? What first appears to be a compound and basic decomposition, as I look further, I realize it involves a carbonate. Remember, when you have a carbonate, let's bring back my generic, it's a metal with a carbonate, polyatomic ion. What happens? My metal teams up with oxygen, so I have sodium. Let's just remember, sodium is +1, oxygen's 2-, so I need to write this correctly. I need 2 NAs and 1 oxygen, okay, and that's the solid, plus CO2 gas. Okay, and then I have to balance it, 2 NAs, 2 NAs, 1 C, 1 C. 3 oxygens, 3 oxygens, so it's balanced. So something good to write is that on your generic ones, you usually start with a solid, and you make a solid and a gas. Let's bring back our other generic one, equation, and do the same on that. You start off with a solid, and it breaks down into a solid and a gas. decomposition of two different types of reactions. That's it.